Hey, this is a homework packet tutorial. This is page 1 of the homework packet for the second unit. It's over electron configuration, so you're definitely going to want to have your periodic table handy so that you can follow along doing the electron configuration. So I'm going to do a few of these. I'm going to start with, we'll start with lithium here. We'll find lithium on the periodic table. Lithium is right here. So that first row has electrons. I'll get both of them in here. First row has electrons. So 1s2 is full. Okay, that means you go down to the next row. So you go down here. This is row 2, period 2. That's where lithium is. So that's 1s2, 2, it's in the s block. It's the first electron, so 2s1. So my electron configuration for lithium is 1s2, 2s1. Alright, how about fluorine? Fluorine is all the way over here in the halogens. Okay, it's in the second energy level. It's way down here, 7 valence electrons. So, I guess we can do it here. Go 1s2, because both of those are full. We're not to fluorine yet. You skip down to the next row. 2s2 is filled. Skip over. 2p, well there's fluorine, so it's 2p, 1, 2, 3, 4, 5. 2p5. So for fluorine, be 1s2, 2s2, 2p5. How about titanium? Titanium, it's a transition metal. It's in the middle. It's right here. Okay, remember that the transition metals, their energy levels have been kind of moved down a row. So this starts 3D. This is the D block. So it's 3D1, 3D2. Okay, even though I know it's in the fourth period, 3D1, 3D2. So this electron configuration will go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Okay, so it goes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. If you're confused, rewind it and watch me do it again. Okay, let's look at a couple of these questions at the bottom. They're easy. According to the Heisenberg uncertainty principle, we can't know an atom's an electron's what? Position and velocity at the same time. An orbital is a 3D region around the nucleus where an electron is likely to be found 95% of the time. And the current model of the atom is called what? It's called the quantum, I'm sorry, I can't spell. Quantum mechanical model. Okay, over on page 2, if I can separate the pages, page 2, we'll do some orbital notation here. Okay, so hydrogen is located right here. Okay, so it's in the 1s and it has 1 electron. It's the first electron in that 1s block. Okay, so it just gets 1 arrow. Okay, lithium, right below it, 1s2, 2s1. So that means in the 1s block, there are 2 electrons. They spin in opposite directions, so you have to designate that they're spinning oppositely. In the 2s block, this is right here, it's just 1 electron, 2s1. So that's 1s1, that's 1s2, 2s1. So you can kind of follow along. Carbon, over here, 1s2, so there's my 2 electrons there, 2s2, 2p2. Remember that they have to occupy orbitals by themselves before they share orbitals. So this does not work. Okay? Every electron gets its own orbital by itself until it has to start sharing sharing orbitals. Okay, they get their own until they have to start sharing. All right, let's see. How about potassium? Do potassium. Potassium's right here. Okay, so that's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, I like to write the electron configuration when I'm doing these first. So I'll do it over here. 1s2, 2s2. It keeps me on track. It keeps me to where I know what I'm doing. Okay, I don't get lost in all these arrows and numbers and letters. It just helps me to stay on track. So 2p6, 3s2, 3p6, 4s1. Okay, so in the 1s block, I got 2 electrons spinning in opposite directions. 2s block, 2 electrons spinning in the opposite direction. P, there are 3 little p orbitals. 1, 2, 3, 6 electrons. 1, 2, 3, 4, 5, 6. 3s2, there we go, 3s2, 3s2, there's 2 electrons in there. 3p6, there are 3 little p orbitals, 6 electrons in there, so 1, 2, 3, 4, 5, 6, and finally 4s, 1 electron, 1 little lonely electron in there. Okay, so that's the orbital notation. Okay, noble gas notation for these elements, how about I just do strontium because that's a longer one. Okay, so there's strontium. It's actually not a longer one because it's a noble gas. It's noble gas notation. So strontium, in order to do the noble gas notation for strontium, remember what you do. You go back to the last noble gas that was filled just before your element. So strontium is here. The last noble gas that was filled was krypton. So you put krypton in brackets. Brackets, not parentheses. And then you put the remainder. So it's krypton, 4s, or wait, that's 5s2. Krypton, 5s2. There's that noble gas notation, making our life so much easier. Okay, page 3. Do a few of these. Here's some of the odd problems, I think. The configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9 belongs to the element where? Okay, well, period is going to be tricky because it's in the 4th period. So I think the easiest way to do this is to find the element. So you go this number here. Here's your periodic table. And it was, let's see, 1s2, 2s2, 2p6, 3s2, 3p6, almost there, 4s2, 3d9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's copper. So this is copper. What group is it in? Okay, it's in the B groups. The transition metals are the B groups, so this would be 11B. And what period? It's in the 4th period. Yes, I know its valence electrons are in the 3rd energy level, so in the 4th period. Be okay with it. Let's see, what is the noble gas notation for titanium? Well, golly, I think I just did that. No, I didn't. I just did the electron configuration. So for titanium, we go back and we see what is the last noble gas that had electrons before titanium. So you go back. Argon. So it's argon, 4s2, 3d2. Those are wrong. Argon, yep, there you go, 4s2, 3d2. Okay, noble gas notation for silicon. Silicon is Si. The last noble gas filled was neon, so it's going to be neon, 3s2, 3p2. Oh, that's germanium, duh. Three S2, 3P2. Okay, so let's look down here, number 27. Let's see explain the mistake the student made in completing the diagram for carbon. Fix the mistake on the diagram. Well, that's not a great diagram, okay? But I see what the problem is. This should look like that, and that should be down, and that should be up, and that should be down. That should be up, and that should be down. Okay, well, first of all, that can't happen. Every electron gets its own orbital before they have to start sharing orbitals. So this is wrong. So it would be 1s, 2s, 2p, there's my 3p orbitals, da-da, da-da. There you go. It's fixed. So what's the mistake? 2 electrons cannot share orbitals. Oh, somebody's calling. Let me put you on hold.